And those who didn't come to this class, I'm just gonna recap that, the last classes, and what we have done actually, the distance and the displacement. We talked about the distance. Actually, remember, this is not the theory class, actually. But I will explain this theory and also the model questions, and sometimes we'll do the past paper also, no worries. And these 10 terms, the distance, displacement, speed, velocity, acceleration, deceleration, gravitational acceleration, distance versus time graph, displacement time graph, velocity time graph. Another one, the 11th one would be the gravitational acceleration. Yes, 7th one. So this 10 term would be discussed, should have been discussed. When you were studying this theory part, it should have been discussed here, right? Okay. So here look at this one. The last classes we discussed something about the what is distance and what is displacement. The total length of an object, and which is called distance, and this displacement, the distance between the starting point and ending point, and that is displacement. I'm just revising the last classes, right? Here look at that. So the distance and displacement, if you look at this one here, the distance and the displacement, I will send this PDF, right? What is the difference between distance and the displacement? The starting point, ending point length, and that is displacement. The total length of an object, and that is distance, right? But here, I have given with some errors. So we found that error here. I put here these 5 errors here. What is error? Here, the starting point, ending point, the distance between the starting point, ending point, and that is displacement. It should be 40, and I have put here 50 because you should find these errors. Right. And also, the last classes we discussed about the speed. The speed is the total length of an object which is traveled in a unit time, and that is speed. And the speed is equal distance over time, and the unit ms minus 1, and it is scalar quantity. If you want to find this distance, you multiply the speed into time, and dt, distance. That's why I have put here dt, distance into speed into time. And the graph for distance time graph here, and this distance time graph, if you look at that, the speed is equal y over x. If you want to find the speed, and this you should divide this y-axis over x-axis using graphs. These were discussed last class. And some of the distance time graph, and this is rest, and this would be also rest, and this is constant speed, which is one direction, and this is another direction. Look at this one. This is one direction, 40 meter, and this is it's 140 meter has gone one direction, and this graph is one direction. Another direction here, it come back, right? I'm moving faster because why? Actually, this was discussed last class. Okay, look now. And also we discussed this one last class, the velocity. The velocity, the term which is being used in within the connection between the displacement and time. The velocity is equal change of displacement over time. The final displacement minus initial displacement over time, and that is velocity. And the velocity is, as we know, that is vector quantity. That is a vector quantity. Excuse me, wait. Okay. And also, if you look at this one, the graphs, displacement time graph, and this displacement here, I have put displacement, and the time here, this time, and V is equal displacement over time, and displacement equal V into T, velocity into time, and displacement which is given in a y-axis, and time is given in x-axis, and m is equal y over x, and m should be here is velocity. In displacement time graph, the gradient of any graph, that gives the velocity. Here's some of the graphs you can see here. Displacement time graph, and this is rest, and here this is also rest, and this is constant velocity, and this is also constant velocity. So these things we discussed last class, right? And also we looked at this acceleration or deceleration last class. Acceleration means the change of velocity over time. The change of velocity means Vf minus Vi over time, which means velocity, final velocity minus initial velocity over time. If velocity is greater than this, the final velocity is greater than this initial velocity, and that would be acceleration, which means the velocity, change of velocity, if this change of velocity, if it's a positive, then acceleration would be positive. If the change of velocity is a negative, then the acceleration would be negative. The negative acceleration would be called deceleration. Deceleration means the velocity decreasing. We will be talking about all these when we do these the questions. And we looked at this one. The velocity is equal. Here, look at this one. So I will explain here. Wait. Right. Okay. Did I explain that velocity is some acceleration? Can someone say please? I forgot that. Did I? Last class people? Did I explain that velocity time graph? Anybody say please? Please say someone. Okay. Did I? I couldn't hear. So the graph which is drawn with velocity in y-axis, the time is x-axis, which is called what? Velocity time graph. In velocity time graph, I am taking this shape graph. Now look at this one. This is a y-axis and this is x-axis. This is the small theory about these things. And the acceleration equal change of velocity over time. We looked at that, the change of velocity over time. Change of velocity, I am taking for easiness, I am taking this is V. But here above, you remember that the change of velocity, not the velocity. So now I can write V is equal A is A into T. Here now look at this one. This is V we have given in a y-axis. So it should be y-axis. And T which is given, we have given x-axis. So we are giving this x-axis. And here this A would be here now is M. Y is equal M. So A would be now here M. So I substitute that y is equal, instead of instead of m, I put here a and x. Now here a is equal, acceleration equal y over x. Which means if you want to find this acceleration in this graph, you should find this y-axis over x-axis. So if you look at this one, this is how it is find in the graph, or using graph the acceleration can be found. If you look at this one now, I'm showing some of the graph, velocity time graph. This is the one what I have drawn there. This is the one which I have drawn there, right? Okay, now look at now. Some of the velocity time graph, this is a very important. I will send this one. Should not be shared to anyone. It takes so much of time to draw this one. It's very clearly shown this one. So I'll show it. It can be shown using this one. It will be very much easy, right? Okay, look. Can you see? Can you see?
Yes, sir.
Yeah, okay.
Yes, sir.
And this is a very important part of the linear motion, the velocity time graph. Usually there are two types of graph will become, that is displacement time graph and velocity time graph. Here if you look at this, the different types of velocity time graph. See, this is velocity time graph here, which is given in a rest. Here, look at this one. This is rest point. Which means here velocity. You should remember this one, otherwise it's tough. Here, look at this one. The second graph, which is what? This is constant velocity. It is a constant velocity. Which means here there should be a one velocity in this point. There should be a one velocity, and that is constant. That is constant. It's really tough to teach this linear motion in this manner. It's really tough. But I have tried so much about these things, right? So please very much carefully understand these things. The Natara short notes in clearly very easy to understand. So if it's a 40 ms minus 1, it will be constant here. This is the red color shows, this graph shows what? The constant velocity. Here velocity time graph, and here time, the constant acceleration here. For example, if someone say, please, I am changing this one into displacement and time, and here this graph would be what? Can someone say? I am changing this velocity into displacement. Now what would be this one? Constant. Instead of constant acceleration, what would be that?
Constant velocity, sir.
Constant velocity.
Constant velocity, exactly. If it's a velocity time graph, and this would be constant acceleration, and if it's a constant, the displacement time graph, and this would be constant velocity. Why I am talking here, listen here. If it's a displacement time graph, this graph is constant velocity. If it's a constant velocity, the velocity time graph, this graph is a constant velocity. Look at the connection. Velocity time graph, this is the constant velocity graph, and if it's a displacement time graph, this is the graph. We will be doing the, I have compared that one. I have compared all the things. I will give that one, don't worry. And then next one, this graph is, which is started with a velocity. For example, if it's a 20, if it starts with velocity, constant acceleration, and this is constant acceleration, this slope with velocity, which means the velocity start from here. And this one is velocity time graph. The graph which is coming towards here, this one, look at this one, this point is 0. And that's why we call this one constant deceleration. For example, if it's a 40 ms minus 1 and it coming, and it becomes here, it would be a time here, but don't see this time. Abhiyo inga varum. Inga vanda enna irukku? 0. So velocity 0 means it became rest. Velocity 0 means it became rest. Look now at the same time, look at this one. The graphs which is has to be done very clearly, has to be studied very much clearly. Look at this one. This is gravitational acceleration graph. You know what is gravitational acceleration? You know, gravitational acceleration is the constant value. The constant value which is forming by Earth. Earth is attract any object, and because of that, acceleration is formed. And when an object falls from one point, right? When an object falls from one point and it falls down, when it falls down, we can call this one gravitational acceleration, because every time the velocity, for example, if it's fall, means the velocity would be 0. When we do this question, you will understand very clearly. And when it falls after 1 second, this velocity will change into 10 ms minus 1. Gravitational acceleration. After 10 seconds, 100 ms minus 1. After 100 seconds, 1000 ms minus 1. Every second the velocity increasing when it falls down. So when it falls down, why I have put this plus here now, the change of velocity, if it's a positive, that is acceleration, and this acceleration is the constant value. Simple as சொல்றனே, ஒரு பொருளை நீங்க தூக்கி சும்மா போட்டாலும் gravitational acceleration 10 தான். நீங்க மாடிக்கு மேல ஏறி தூக்கி எறிஞ்சாலும் gravitational acceleration 10 தான். This is a high class physics. இந்த லிங்க் 10 நிமிஷத்துக்கு போகும், எண்ட் ஆகும், அது போகும், அடுத்த லிங்க்கு போகுமா? Wait for 10 minutes, right? Not wait for. This will expire by 10 minutes and I'll give another link. Look at this one. That's why the graph, this is acceleration. எல்லாரும் நினைச்சிப்பீங்க இந்த கீழுக்கு போல் போகுதுண்டா கிராஃப் கீழுக்கு தான் வரும் நினைக்கப்படாது. Don't think like this. If when it falls down, that is gravitational acceleration. And acceleration graph, this is the graph, same as this one. At the same time, you are throwing one ball from the earth. For example, if an object throws 40 ms minus 1, in every second the velocity would decrease. 40 1 second la 30 ஆகும் 30 20. Change of velocity is a negative. Change of velocity is a negative. Negative means negative acceleration. Negative means negative acceleration. Negative acceleration means deceleration. Change of velocity is a negative. If it's a negative, that is deceleration. Change of velocity is a negative, that is negative acceleration, and the special name for negative acceleration is called deceleration. And here it is happening in a gravitational earth. So gravitational acceleration here, what is the symbol here? G minus. If it's a minus, then it would be, if it's a minus, then it would be, the graph would be, what's this guy? If it's a minus, then the deceleration, the graph, this is the equal this graph. Look at this. Excuse me, wait. At the same time, remember, now if the ball is throwing up, when it throw, this is G minus. So if it's a G minus, the graph would be something like this. Look at this. The graph would be something like this. Then the ball goes to maximum height. When this ball goes to maximum height, it reaches velocity 0, then come back again. Very important point here. This is one direction and this is opposite direction. Excuse me, whose sound is coming? Data. The guy is disturbing always. Shit. And when this is one direction, then balls moves upwards, and that is one direction. And when ball falls down, and that is another direction, opposite direction. Now, okay, this is when it falls down, sorry. When it falls down, this is falls down, when it goes upwards, and that is negative acceleration, which means deceleration. This would be the graph. Okay, this has been drawn here. Then when it come back, that is opposite direction. Opposite direction in velocity time graph, மேலுக்கு time axis க்கு மேல time axis க்கு மேல கீறப்படாது. Very important. இங்க மட்டும்தான் opposite direction problem வரும். Ball மேல தூக்கி எறிஞ்சி கீழே வரும்டா. When you throw a ball and if it's come back again, the graph would be here. கீழுக்கு graph வரும், which means it will be drawn downside. This is one direction. And the direction is opposite direction. But here this is what in the graph if you have drawn in a notebook 180 degree cricky pathingana. If you have turned it down, then idu mele pora maari irikkum. If you have turned it down, you turn your mobile. When you turn your mobile, don't turn your laptops if you are connecting with laptops. So if you are connecting mobile phone, you turn it back. If you turn it, idu mele pora maayikkum, which means this is opposite direction, and that is a gravitational acceleration positive. And the velocity time graph opposite direction and very important. So these are some of the theories, right? I'm stopping here. We'll go quick fast. We have to discuss so many things, right? I'm stopping here. Come to next link.
Yes, sir.
Okay, look this now. If you look at this picture, then you will understand the basic idea. This is rest, this is constant velocity, we know. The constant acceleration, this is the one. If it's a constant acceleration, this is also constant acceleration. And this is constant deceleration. Okay, this is constant deceleration, no problem, because gravitational deceleration. But ஒரு ball மேல போய் கீழே வரும்டா, மேல போனா that is deceleration. Okay, then when it come back to acceleration, and that comes in an opposite direction. When it comes to this opposite direction, you should draw below this velocity time graph. That is the very important point when you do this one. I'm expecting this kind of question or this chapter question this year, because simply they will put so many questions in grade 10. Why I am saying, because why? It's not about corona. If you look at this past paper, the grade 2019, they have what poured 2000 grade 11 physics. So definitely they will come to grade 10 physics. It will be very much easiest questions and you can easily study. Wait. Another one, this is the most important thing. Most of you people are very much confused. Loads of people confused about this. Lots of people confused about this. Look, I have put two graphs here. Look, I have put two graphs here in a same view, right? Look, now this is displacement time graph and this is distance. Here, this is what we call constant velocity in displacement time graph. And if it's a constant velocity in displacement time graph, here, look, the displacement would be 50 meter. So distance would be 50 meter. How could possible in displacement time graph distance? எப்படி displacement time graphல distance வரும்? என்ன கூத்து இதுன்னு யோசிப்பீங்க. Look at this one. This is the orange color. The starting point here, the ending point here. The object is moving a 50 meter. It's a 50 meter move. So here, the displacement and the distance is equal. For example, உங்களோட வீட்டுல இருந்து ஹிஜ்ரா ஜங்ஷன் அடி போறீங்க. போனா not ஹிஜ்ரா ஜங்ஷன். In your home, you're just moving straightly one place to another place. You're moving 50 meter. If you're moving 50 meter, the total length of an object which is traveled is 50, and that's why it is distance 50 meter. And the starting point and ending point also, the distance between starting point and ending point also, that's also 50 meters. So in this displacement time graph, distance and displacement is equal. But if you look at this one, this graph, which you have to know very much carefully, this is one direction. Look, here it's at 0. It's 50 now. Which means it is increasing. It moves 50 meters. This is starting point. And this is ending point. It's moved 50 meters. Then it come back again, and this blue, the green color is opposite direction. Which means the time axis இங்கிருந்து மேல போன ஒரு direction, displacement time graphல கீழ வந்தா இன்னொரு direction. But in velocity time graph, and I was talking about this, in velocity time graph, time axis கீழ வந்தாதான் opposite direction. But in displacement time graph, time axis if it go away from the time axis, if it's gone away from the time axis, and that would be if it's gone away from the time axis, and that would be pause one direction. அது அப்படி கீழ வருமன இன்னொரு direction. Look at this one. In the picture very clear ஞாபகம் வெச்சுக்கொள்ளுங்க. This is the orange color. This is one direction and this one. Another direction, it's coming back, and this is another direction. That's why it came here. இங்க வந்து சிலாக்கள் என்ன இரண்டு அந்த டைம் ஆக்சிஸ் எடுத்து பார்த்துட்டு இவடத்து ஒரு 40 இருந்தா sorry. For example, if you have this 20 meter, or 20 meter irunda, sorry, 20 second. If it's a 20 here, the 20 one, they will use this 20. You can't. This is time axis where you should move. You should bring your eyes here. Here now what is the value? Is 0. So displacement 0. போனது 50. அப்படியே பேக்காய் வந்தது 50. முன்னுக்கு போனது 50 and this is 50. Then come back again another 50. Total distance, that's why here 100. Remember one thing, or a booklet in velocity time graph, I will talk about later, but I'm saying that one, they have asked sometime distance or displacement. Mari கேட்டிருப்பாங்க. If it's in one direction, in a straight motion, if it's in a one direction velocity time graph, they can ask distance or displacement, no problem. Both are same. And the book problem that's correct. I can show sometime. I'll show that later. But here in velocity time graph, same picture. Random same picture. Here the distance 50, displacement 50. Here if you want to find this displacement, you should find this area. Displacement time graph அப்படியே graph கையில எடுத்துக்கிட்டு எங்க முடியுதோ அங்க முடியிற இடம் displacement ஆயிருக்கு. Look here. அப்படியே எடுத்துக்குவாரு. You bring your pen and I'm bringing again here. Now it's reach here and you come to here. Now displacement 0. But in velocity time graph, you can't do something like this. In velocity time graph, to find the distance or displacement, why I have put this distance? Because in the time axis is a graph, so no problem. Both are correct. Time axis is a graph. It is drawn above the time axis. So displacement or distance would be area of triangle. Area of triangle. Mukkonida param. And distance, I used to use distance displacement dt, and distance is dt, and displacement equal half into this base into perpendicular height, and base is half, base is a, and the perpendicular height is h. This is how you should remember. Very important in a one side, the one picture, or picture இதுக்கு கொஞ்சம் பேரு இந்த கிராஃபுக்கு இத காணுவாங்க. இந்த கொஞ்சம் பேரு இந்த கிராஃபுக்கு இந்த கிராஃப் இப்படி காணுவாங்க. Don't confuse yourself. Don't confuse yourself. I'm saying that don't confuse. Here, look at this one, displacement 50. The same picture, if it's a 50, and for example, if it's a 5 centimeter, 5 second, and if I say, for example, half into 15 to 5. 50 into 50, 250, 250 over 2, 125. For example, but here is 50 and 5, here displacement 50 only. Here, oh God, here only you should come to this point. Starting from the pen at the displacement time graph, the final displacement curve. pen enga mudido anga mudirada vechittu come to left side and see the displacement enga ividate ettinirikku, that is displacement. This is how you should do this one. I can't do revision, is very much tough using the theory. Theory kadachim paper share very custom, but I have tried, right? Okay. Now let's go to next one. This is, don't confuse yourself, right? This is very tough. I have tried so much of things in one picture. If you are well enough in linear motion, this is the picture. If you have understood very well, right? If you have understood very well this 2-1, you will understand every question. This is displacement time graph. This is velocity time graph. Same number, same times, same questions, but you can't ask same question. I will send this one, right? I am not going to explain this one now. I will explain this one next class, right? I'm going to do some question now, right? The basic idea, if you see this, the constant here, this constant velocity, this graph, the displacement time graph. Here the velocity time graph, this is constant acceleration. Here the displacement time graph, this is rest. And this velocity time graph here constant, this is constant velocity. In displacement time graph, this is constant velocity, opposite direction. Look at this picture. It's come back again. I was talking this one. And here this one, when it come back in velocity time graph, this is constant acceleration, the negative one. Negative acceleration is called deceleration. Look at this picture here. From 0 to 4 second acceleration. 4 to 8 second constant velocity. I have put V here. Then 8 to 10 second. This is deceleration, but same direction. This is same direction. Because time axis is the male. But here this point only opposite direction.
இங்க பாரு ஒரு இவ்வளவு வெயிட் தெரியுமா? டைம் எத்தனை நம்ம சரியா 10 11 கூட்டு பண்ண 10:39 ஆயிட்டு.
And now the constant velocity in 4 seconds, if you look at this, the constant velocity in 4 seconds, 40 over 4, 44 ala pirichirikken ethana varum 10 ms minus 1. Here you can't ask constant velocity. I have asked constant acceleration here. Look, 40 over 4, 40 over 10 ms minus 2. Here 10 ms minus 1. Most of the people இந்தையும் இத மாதிரியும் இதையும் கன்ஃபியூஸ் ஆகிற ஒரு ஆட்கள் தான் நீங்க. Most of the people displacement time graph, velocity time graph வச்சுக்கிற velocity time graph வச்சு மாறி you will confuse every time and collapse. If you see this picture, if you have this idea, you will never ever forget. Remember one question idea, then you will not forget. See the constant velocity in 8 to 10 seconds. Y over axis, this y is 40, this x-axis is 10 minus 8, 2. 40 over 2, 20 ms minus 1. And I have asked here, this is the one, constant x deceleration here. A is equal y over x. This y-axis is 40. 10 minus 8, 2. 40 over 2, 20 ms minus 2 here. Do you understand the basic idea of this picture? You should. Here the total displacement in the graph, starting point, I'm moving this. Total displacement cut as a move and one thing, lots of people give the answer, what's that, you know? In answer, can someone say this 10? And a can about 10. But the total displacement in the Vanda, you bring this one here. This point is 0. So the total displacement is 0. But total distance is not 0. In a displacement time graph, like distance here look at this one. In the 40 40 and find error sum here. If it's a 40, then answer should be what? I forgot that. Look at me. It was a mistake. What's that?
80 meters.
80 meters. Who is drawing? Okay. 80 meters. It a and rest. And here this is opposite direction. உதாரணத்துக்கு உங்களோட வீட்ல ஜன்னல்ல இருந்து நீங்க கேட்டுக்கு போறீங்க 40 meter. கொஞ்ச நேரம் ரெஸ்ட் ஆகுறீங்க. Then it come back again to that window place. So போனது 40, gone opposite one direction and come back again another opposite direction. Total length of an object travel, and that is called 80. But starting point that is 0 displacement. But here, if you want to find this displacement, you have to find this all the area. Area of trapezid. Here 10 plus, here 10. Samandara Pakka means what? The length of parallel lines. The 10 plus, and this gap is how much now? 8 minus 4, 4. What's the answer? What's the answer? 280. Look, they will give these marks here. They will give marks for 1 here. Another marks 1. This one for 1. And they will give this one for 1. And they will give this one or 2. This is how they will ask. They will give the marks. Here they will give marks 1, 1, 1, and a 1. If they ask to draw this picture or this graph, they will do 2. Agar Ansar, are you crazy? This sound is coming out. Okay. So
mute பண்ணிதான்
mute it. So I will send this one. Please correct here, right? I'll correct this one later, then I'll send it. Okay, this is how you should understand the basic idea of this linear motion, right? So this is how you should remember. I will send this everything, no worries, right? So look now, I'm going to move now the question part. I'm starting now the question part. So I was discussing this one, these everything. So which will be included in this one. Okay. And I'll put this so much of question. If you have any doubt in theories, please let me know, right? Please ask. And this question related to distance and speed. And we will go to next question would be the velocity and displacement, that kind of question. And we'll move to acceleration question. And also we'll go to gravitational acceleration question, and also we will move to past paper model question, and we will move to past paper question, and we will finish this one. The first one, what's that question? Let's do that. Can someone do? An object travels 400 meters in a straight line. An object travels 400 meters in a straight line in a constant speed. Find the speed of it. Simply, what is that equation you should be used? We studied what speed is equal
Distance over time.
distance over time dt over t. The symbol loads of people changing this symbol. Speed u poduvaanga, v poduvaanga. They will use something. Why are you playing that one? You just write something like this. Speed is equal distance over time, no problem. Distance over time. It will take only 2 seconds, enough. How much of distance? 400 meter. The time is how much? They didn't give. The time is not given. So I'm going to give this time now. In a 400 meter straight line, in a constant speed, for 20 seconds. For 20 seconds. What's the answer now?
Sir.
20.
I'm cutting here 0, 0, 40 over 2. What's that? 20.
20 ms minus.
And S-ing on the one, if it goes upside, then the standard unit of speed is ms minus 1. Very simple question. But how they will ask, you know, this class will end by 10 minutes, right? 10 minutes or more. I'll finish this one faster and the class and I will speed up even, no worries. Instead of this 20 seconds, or 5 minutes in the instead of 20 seconds, they are giving 5 minutes. Now what you will do, you people know everything, no? Speed is equal distance over time. What you will do? Distance 400 and they are giving 5. 400 over 5, how much? 80 ms minus 1. Now let's change the lancheri. Can you do? Can you
No.
do? You
No, sir.
can't.
No, sir.
This minute should be changed into
Second.
second. Very simple question at but you will get this one by mistake. Definitely speed is equal 400 distance over, if it's a 5 minutes, 5 into minutes, 1 minute equals 60 seconds. So 5 into 60 seconds. That's why I use these units now. Now you can put this answer in a meter per second. I can cut 40 over 30 and the answer would be 4 over 3 and the answer would be how much? 1.33
3
ms minus 1. Look at the difference of that answer and this answer. MCQ le rendu answer vidari. So please understand the basic idea. In this one, it should be in a meter. If they give this a 4 kilometer now, the basic idea now. Now what you will do now? You will have very much expert now. Speed is equal distance over time. What you will do actually 4 over 20. Cut pandram 1 over 5 0.2 ms minus 1. Correct? Is it correct? Never.
No.
You should change
Yes,
this kilometer into meter. இப்பெல்லாம் கொஞ்சம் ஐக்யூவா யோசிக்கிற கேள்வி இல்லாம this unit change இல்ல மயக்கம் போட்டு வச்சிருப்பாங்க. Read it well and take up only 40 MCQ, only 1 hour. You can do that MCQ paper within 40 minutes, enough, even a half an hour. Even if you have studied well in science, you will do those questions within, I think, 1 hour you can finish all the questions if you have studied. Because science is very easy if you have studied. They will ask question 35 students and everyone. Studying well, very much wrong. Studying too much of time, that's not good. What I am saying is one, study smartly. Smartly studying, otherwise you will confuse and you will what's that? You will forget everything. Studying smartly means this is the way. If it's a meter, meter tandirukku. If it's a kilometer, then you should change. If it's a minutes, if it's change. If it's a hour, you should change. Something like that they will ask. Now you can find, you can do this one. If it's a 4 kilometer, speed is equal 4 kilometer over 20 seconds. You can put 4 over 20.2 kilometer second minus 1. This is correct. But is it an international unit? No. If it's not an international unit, what you have to do actually, you change that 4 kilometer into 1000 meter is equal 1 kilometer. So 4000. The maximum, the type 1 question, they will ask something like, they will change this unit and blah blah. Okay, the next question. This class will end by 3 minutes. Okay, the type 2 question. An object travels with 50 ms minus 1 constant speed for 50 seconds. Find the distance of it. If idea ennada adu, speed is equal distance over time. Baba question. Normally I used to say these questions are Baba questions, baby questions. They have given a speed, they have given a time, and they have asked what distance. Simple. What's distance equal? You multiply speed into time. Speed S into T. Speed how much? 50. Time how much? 50. Look, this is second minus 1. This is second. When it multiply, both will be cut. Then 50 into 50, 500 meter. And the answer would be 2.5. What's that? Kilometer. I hope you got it. And I'm stopping from to this one. And stopping from this one. If you haven't understood this one, I will send this video, today's video only, because I can't send other videos. All the time, don't ask this video, because please try to attend the class, right? And I'll give something. It's not about what's that. This class is all about like a service, right? Because within 5. Don't study after this one. Assalamu alaikum.